Hello sir, my name is D. Satyapranay. My registration number is 20BAC0300 and my slot is TD1. Now in this video, I'm going to explain a project I've done using an ultrasonic sensor. The project I've chosen for this session is a distance measurement device, and the sensor I'm using for that project is an ultrasonic sensor, and this is an ultrasonic sensor, and this is a specific module of HCSR04. This module has 4 pins: voltage pin, trigger pin, echo pin and ground pin. Voltage pin and ground pin are responsible for providing energy or voltage to this sensor. Trigger pin and echo pin will act a major part for calculating the distance between the sensor and the object. Now we'll just look at how the sensor works. Now, an ultrasonic sensor works by emitting and receiving ultrasonic waves. This is the transmitter which transmits the ultrasonic waves, and this is the receiver. Now, the trigger pin and echo pin will help in transmitting and receiving the waves. When according to the program, we write in Arduino and we connect the sensor to in the breadboard, and when the trigger pin gets activated, the transmitter will emit ultrasonic waves in a set of 8, and they emit 8 set of ultrasonic waves because if there are any ultrasonic waves in the surroundings, the sensor won't get any miscalculations or there won't be any errors. So because of that, the receiver only identifies those 8 set of ultrasonic waves reflected back if there is any object present. When the trigger pin gets activated, the transmitter sends ultrasonic waves, and when that happens, echo pin will go on high, and when the ultrasonic waves reflect and received by this receiver, the echo pin turns low. The ultrasonic sensor will calculate the time between the transmitted wave and the received wave, and based on that they'll calculate the distance between the object and the sensor. We're going to connect the ultrasonic sensor and Arduino using the breadboard and the circuit. Now we have connected this ultrasonic sensor with the Arduino, and the voltage is connected to the 5 volts in Arduino, and the ground is connected to the ground. The trigger pin is connected to the 13th pin in Arduino, and the echo pin is connected to the 12th pin. Okay, now this is the code I use for this ultrasonic sensor for this to work. Now here we have defined echo pin and trigger pin. We have defined echo pin to 12, so here we connect the echo pin to 12 in Arduino board, and we connected trigger pin to 13 and we initialized it here. And here we take two variables, duration and distance, and we initialize it. Duration is a long number and the distance is an integer. Long is nothing but an integer with decimals. Now we have the void function and this setup function, not the void one. We have the setup function, and this function runs when the program starts uploading and whenever the USB is connected to the Arduino board. Now we are just initializing the trigger pin as the output pin and echo pin as the input pin, and we give a delay between the input and output. We also have the loop function here. Loop function runs as long as the USB is connected to the Arduino board. It runs in loops. That's it. Now we initialize trigger pin low. That means there are no ultrasonic waves emitting from the transmitter, and after 2 microseconds the trigger pin will be high. That means the ultrasonic sensor will start emitting ultrasonic waves from the transmitter, and with a delay of 10 microseconds the trigger pin will become low. That means after 10 microseconds the ultrasonic waves stops transmitting. So then we calculate the time between the transmitter and the received waves using this pulse-in function with echo pin. Like when the waves are transmitted, the echo pin will be high, and the waves are received, the echo pin will be low, and based on that we'll calculate the time between the receiving and transmitting. With that we can calculate the distance by duration into velocity of sound at room divided by 2. Like if there's object present here, when the ultrasonic waves travel to the object from the sensor and from the object to the sensor, it makes a cycle, and due to this the waves has to travel twice from ultrasonic sensor to object. So we divide it by 2 to get a perfect distance. Now we have the serial print distance, and this will give the distance in the serial monitor. Now I already uploaded the code in Arduino board. Now we have already connected to USB. Now here we can see the distance is showing as 60 or 59 centimeters. This is because the ultrasonic waves, if the ultrasonic waves aren't received within 30 millisecond interval, the echo pin will be low by default. So because of that we'll get a high value, and this module can calculate the distance between the object and sensor, like about 30 centimeters I guess. See, the object is at 6 centimeters and it's showing 6 centimeters, and the object is at 5 centimeters. We can see the 5 centimeters, and sometimes it's 4. Now it's 4, 3, and when we increase the distance, as we can see, the output also increases until 12, 13. That's it. This is how the ultrasonic sensor works. Now I think I'm gonna make a few modifications, like adding an LCD board, and I'll show you. Okay, now this is a little bit modified version of my project. I've just added this LCD screen to this project. I'm gonna explain the code for that. There are just little changes. Here we have hashtag include, and we've included a library from Arduino board which will help us initialize the values and display it on the LCD board. And liquid crystal LCD 11, 10, it will just say us what the pins are initializing. Like here we have the numbers for pins. This is 11, 12, 13, 14, like that. Like which pins are connected to which pin, like some pins are connected to the 11th pin Arduino board, 10th pin in Arduino board, like that. This is the normal code from the earlier thing. And here we have LCD begin 1612. Here it's a 16 by 2 matrix, and set cursor 0 0 0 0 means the first block of the 16 by 2 matrix. And as soon as we run the code, we get this distance colon printed on this LCD screen. Due to the glare we can't see it properly, but from the side we can observe that distance colon. And here we just modified the code so that the calculated distance will be displayed here. So as you can see right now, the distance is 63 centimeters. That's because there's no object in front of the sensor. Now I'm bringing an object at 13 centimeters. See, it's 13, now 14, and as we move it closer to the sensor, the distance decreases gradually. And see, 15, it's a 30 centimeter scale, and up to 32. See, up to that we can calculate it, but if there's no object, it will show an error. You can also see it from the serial monitor. We'll get the same output from the LCD screen and the serial monitor. As you can see, the outputs are same. So that's about my project. Thank you for watching this video.